So this is problem 277. I went ahead and wrote down the given and the problem. You're better off looking at the drawing in the book. And we're supposed to find the magnitude and coordinate direction angles of the resultant force and sketch the vector on the coordinate system. So the first thing I'm going to do is just break down F1 and F2 into the Cartesian vectors, or figure out what those are. So I'm going to start with F1 just as a starting place. So F1 of Z is the easy one. That one's 400 newtons cosine of 60 degrees. If you calculate that, that's 200 newtons. And then for the X and Y components of F1, we have to do the projection down to the XY axis. So we'll call that F1 prime, which I've already labeled over here. That equals 400 newtons sine of 60 degrees. And if we calculate that out, it's 346.41 newtons. So now we want to get F1 of X. And that's going to equal that F1 prime. So I'm just going to write F1 prime times the cosine of 20 degrees. So if we look over here at this angle, cosine is the one that's closest, which is the X. So cosine of 20 degrees. So that's that 346.41 times cosine of 20 degrees. That's newtons. And that'll give us 325.5 newtons. F1 of Y is similar, so we take that F1 prime, that projection, down to the XY axis, and then this one's just a sine of 20 degrees. So that's 346.41 times sine of 20 degrees. That's in newtons, and so that gives us negative 118.5 newtons. Actually, is that right? Yeah. F1 of Y is in the negative direction, so that should have been negative throughout. So now we have a formula for F1. So F1 equals, it's the X components, there's 325.5 newtons minus 118.5 newtons. Oh, that's I, sorry. And then J, and then plus 200 newtons K. Sorry, that was a little bit on top of the other one. But so now we have the formula for F1, so now we need to look at F2. So now I need to look at F2. I'm just copying the figure over. So for F2, F2 equals, we know the magnitude is 500 newtons. And so the X component is just going to be that 500 newtons times the cosine of that alpha, which is the angle between the force and the x-axis, which is 60 degrees, I, plus the cosine of that beta, which is the angle between the 500 Newton force and the y-axis, so cosine of 60 degrees J, and then plus still at 500 newtons times the cosine 135 degrees K. I ran a little room there. Because the 135 degrees is that gamma. So F2 ends up equaling 250I plus 250J minus 353.6K. And that's all newtons. And so the resultant force, we can just add those two forces together. So resultant force equals F1 plus F2. So that equals F1 of the X was 325.5 newtons plus 250, because that's the F2 component. And then the Y was, Y was negative 118.5 plus 250. plus, and then the K for the F1 was 200 newtons, and then minus that 353.6, and that's K, and that's all newtons. So we get that resultant force to equal 575.5 I plus 131.5 J minus 153.6 K, and that's in newtons. So we got to the resultant force, but we're not quite finished yet because they wanted us to find the magnitude and coordinate direction angles of that resultant force. So the magnitude, we just do the square root, so the magnitude of R equals the square root of each of those terms squared, so 575.5 squared plus 131.5 squared plus, and it's negative, but when it's squared it'll go away, 153.6 squared. And for that we end up getting 610 newtons is the magnitude. So we'll circle that. And then it also wants us to determine the coordinate direction angles. So for that, we know that cosine of alpha equals Rx over R. And Rx that we found earlier was at 575.5 newtons over, and R we just found was at 610 newtons. So both newtons, so the newtons cancel out. And that basically gives us alpha equal 19.4 degrees. Cosine of beta equals Ry over R. That equals 131.5 newtons over 610 newtons. And that leaves beta equal to 77.5 degrees. And then cosine of gamma equals RZ over R. So that equals negative 153.6 newtons over 610 newtons. So that gives us gamma equals 105 degrees. So now we need to represent it back in the coordinate system. So I had this thing that was connected to the wall. And we have X, Y, Z. And so now we have that the force is 610 newtons, and the alpha is 19.4 degrees from the x-axis. So let's see. And the y is, and it's 77.5 degrees from the y-axis, and then 105 degrees from the x-axis. Or sorry, from the z-axis. So basically that means the alpha, let me get a different color, is 19.4 degrees from the positive x-axis. Oh, I just noticed I did that wrong. Let me go back. Yeah, so x we had done down to the left. So I'm going to change that. Let's see, erase. Maybe something looked wrong. So x and y. So x is 19.4 degrees. So that's this angle here. 19.4 degrees. The angle from the y-axis is 77.5 degrees. And then the angle from the z-axis down here is 105 degrees. So that resultant force looks something like this. This is where the model would be helpful, just to put it there so you can see a little bit more clearly. And that's it.